everybody, welcome to Shel lectures. So today we'll be dealing with states of matter. So the three states of matter are solid state, liquid state and gaseous state. So what are the three states of matter? Solid state, liquid state and gaseous state. These are the three states of matter. So let us look at the properties of each of these. So solid, it will have a definite shape, of course. It has a definite shape and it has a definite volume also. Okay, it has a definite shape and it has a definite volume. And can we compress this? Can you compress this? No, right? So compressibility is completely absent and rate of diffusion is also very low. What is rate of diffusion? Diffusion is nothing but mixing of particles. So in solids, diffusion is highly impossible. I told you that the aroma of the chicken biryani which your mother makes is like smelt by you only because of the diffusion of air particles with the food particles, and that comes under gaseous state. Only gases, the rate of diffusion is very high. In solid, the rate of diffusion is very low. Compressibility is very low, but it has a definite shape and definite volume. Also, it is rigid. It is rigid in nature. And what about here? Liquid, it does not have a definite shape. It assumes the shape of the container. If you are putting it into a Tupperware water bottle, it will assume the shape of the Tupperware water bottle. If you are putting it into a steel water bottle, it will assume the shape of a steel water bottle. Or if you are putting it into a very big anda, then it will be taking the shape of that. Okay, so it does not have a definite shape, but it has a definite volume and it is not rigid because it can flow, right? If you are pouring water here, what will happen? It will not stay rigid, it will just be flowing, right? So it's not rigid, and compressibility is okay, very little okay compared to solids, and the rate of diffusion is not much okay. It's still low. So this is what about liquid, but rate of diffusion compared to solid is high. Okay, compared to solid, the rate of diffusion is high. You know why? In solids, the particles are very compactly packed. In solids, the particles are very compactly packed. That is, the particles are very close to each other. Whereas in liquids, there is a small space which exists between them, and in gases, a very large space exists between them. So in solids, the particles are very close to each other. In liquids, there is a little space, and in gas, there is a very large space. Okay, so from this, this is the reason, the space between the particles is the reason for the rate of diffusion to be higher than the solids. And what about gas? No definite shape, no definite volume, and it can be compressed to a greater extent. Can I compress this gas? Right. So I can compress that to a greater extent, and rate of diffusion is very high, and only because of that you are able to feel the aroma, you are able to smell the aroma of the biryani which your mother makes in the kitchen even though you are in the hall. Okay, so that's all about gaseous state. And then as it is highly compressible, we have a lot of fuels and the things which are filled in cylinders like LPG, and we have CNG. So LPG is nothing but liquefied petroleum gas, and CNG is nothing but compressed natural gas. So compressed natural gas is nothing but the word itself says compressed. So it's being compressed and it can be loaded in very big containers, and it can be transported to very large distances. That's why it's known as compressed natural gas, and it is used as a fuel nowadays. And then this is used in cylinders, right? So only because of its high compressibility, these types of gases are possible, okay, to be filled in fuels and to be used as fuels and to be filled in cylinders. So the highest rate of diffusion in gases, one reason is this, that is the space between the particles are very high, and the other reason is that the particles move with a very high speed. The speed of the particles is very high. That is, in gas, two reasons are responsible for the very high rate of diffusion. One is the particles are very far away from each other, and the next reason is that they move with very high speed. So when they move with very high speed, what happens? I am having a container which is filled with gaseous particles. So when they move with very high speed, they will be hitting each other, and they will be hitting the container's wall, and they will be hitting here and there, they will be hitting, and this is what is the reason for the pressure which is built up inside the container. Okay, as the particles are moving here and there, they will hit them among themselves, and they will hit against the container wall, and this is what is the reason for the pressure which is built inside the container. Okay, so this is all is about the states of matter. Now let us know whether change of states of matter is possible. Can we change the states of matter? That is from solid to liquid, from liquid to gas, or from gas to solid, gas to liquid. Is this transformation or is this transition possible? That's what we are going to learn in the next topic. So the first thing which we have to know under this is the example of water. So when you take the example of water, it exists in the solid form as ice, right? It exists as ice in solid form, and it exists as the familiar water which we drink in the liquid form, and in gaseous form it exists as water vapor. Right, so one substance is present in three states of matter. So from this we can come to know that there is a chance of transition of states of matter, and that is possible. That is transition between solid to liquid and liquid to gas, and the other and the inverse is also possible. The change of state of matter is highly possible because we have a very good example of water here. It's solid in ice, and it's in liquid form it's the normal water which we drink, and in gaseous form it is water vapor. So how is this taking place? Now let us take a solid matter which consists of the constant particles are very close to each other, right? So the constant particles are very compactly packed as far as solids are concerned. So how I will change this into liquid? That is, the constant particles must be just far apart. How can this be done? So when I am increasing the temperature here, that is when I am heating the solid particles, what will happen? I told you in the previous video itself, when we are heating something, when we are heating a solid particle or a liquid or whatever, what will happen? The particles will gain kinetic energy. The particles will gain kinetic energy, and they will start moving here and there very rapidly by hitting the contents of the, by hitting each other and by hitting the contents of the container and all that. Okay, so kinetic energy will start increasing rapidly. So what will happen? They will naturally turn into this state. That is, some kind of a space will take place between them. So what does this temperature actually do? How does this temperature influence this kind of a state of change of state of matter? That is nothing but when you give sufficiently high temperature, there will be force of attraction between these particles. Am I right? As I told you earlier, the constant particles are held together by force of attraction which exists between them. So two constant particles in a matter are held together only because of the force of attraction. So when I am giving a very high temperature from below, what happens? This force of attraction gets broken. Okay, this attractive force gets broken, this attractive bond gets broken. So they just get free to move here and there, and thus they get more free and more independent to move here and there, and thus they enter the next state of matter by melting. A solid changes into liquid by melting. Only if it melts, it becomes a liquid. So this process is known as melting, or it is also known as fusion. So the temperature at which this melting occurs, for example, if you are taking any substance, at this particular temperature, the substance will melt and it will form a liquid, and that particular temperature is known as melting point. So melting point is nothing but the temperature at which a solid substance melts to form a liquid. Okay, so this is what? Melting and fusion. A solid forms liquid due to melting or fusion. Still, if I am heating this, what will happen? Still, if I am heating this, I will be getting gas. Am I right? The constant particles will be very far away from each other, and this process of deriving gas from liquid is known as vaporization. Vaporization. So liquid to gas is known as vaporization. And then, once again, gas to solid. So what should I do for bringing from gas to solid? That is another one thing which we have to learn here. So when the gaseous particles are very far away from each other like this, and I am applying a very high pressure from above, just I am compressing it with a very high pressure, what will happen? All these particles will get combined together, right? All these particles will get combined together. So what is happening? The particles are getting closer, so they have to move to the previous states of matter, right? So gas, it's like that, but this is not actually liquid also. It just gets more condensed that it even goes to the solid form, and that process is known as solidification. And that process is known as deposition. This process is known as deposition. So from gas to solid. So from this we can come to know that either by increasing the pressure or by increasing the temperature, we can change a particular state of matter from the to the other. For example, a solid, if you are just heating it like anything, it will change the next state of matter. And if you want to bring that back, you have to just increase the pressure. Okay, if you are increasing the pressure, you can bring it back. Okay, so this is what is the state of matter change which occurs here. So the two things which are responsible are pressure and temperature. Pressure is nothing but when you are increasing the pressure, the inverse thing happens, that is solid, liquid, gas. So the inverse thing, gas changes into liquid when you are increasing the pressure. Further, if you are increasing, liquid changes into solid. And if you are increasing the temperature, solid changes into liquid and liquid changes into gas. So now let's know, solid to liquid is melting, liquid to gas is vaporization, gas to solid is deposition. So now let's learn this order. Solid to gas is sublimation. That is, solids can get directly into gaseous state of matter without even getting into the liquid state of matter, and that process is known as sublimation. So now liquid to solid is known as solidification. Solidification. And then this is gas to liquid, right? Gas to liquid is known as condensation. And liquid to solid is known as solidification. Let me draw it neatly so that we get a clear idea of. So this is solid, this is liquid, this is gas. So if I am changing it from solid to liquid, it's known as melting. Liquid to gas, vaporization. Gas to solid, deposition. And then liquid to solid, solidification. Then solid to gas, sublimation. One more thing, gas to liquid, condensation. So from this picture we can come to know that the states of matter are possible. So here we have to know one more term which is known as latent heat. So already we learned about melting point, that is the temperature at which melting occurs, and boiling point is the temperature at which boiling occurs. Okay, for example, from liquid phase it changes into gaseous phase. That for example, your mom is boiling water, and when it just gives out bubbles and gets boiled, that temperature is known as boiling point, and boiling point for water is 100 degrees Celsius, melting point for water, freezing point for water is 0 degrees Celsius. So latent heat is nothing but, the word latent means hidden. The word latent means hidden. So that's nothing but, I told you that when a change of matter, when a change of state of matter occurs, there will be an increase in temperature which is given. For example, if it's solid, I am just increasing the temperature which I am giving to the solid, and thus it changes into liquid, but then the temperature still remains constant, right? So where does this heat energy go? Okay, even though the solid gets converted into liquid, the temperature, I am going on rising the temperature, but even then the temperature in the liquid phase is also the same. So where did this temperature go? This heat is taken by the solid state of matter to make its process more easier, and that heat is known as latent heat. Okay, so this is both for melting point and boiling point. When it changes from solid to liquid and I am increasing the temperature, the excess heat is known as latent heat. And from liquid to gas also, the excess heat is known as latent heat of vaporization. So the definition we can tell it as amount of heat which is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point. So at its melting point, 1 kg of solid, if it gets converted into liquid at atmospheric pressure, it's known as latent heat. The temperature which is required for that process is known as latent heat. Okay, so melting point, boiling point must be known. So I told you the effect of change of pressure. When I am increasing the pressure, the gaseous particles change into solid particles, right? So this is, for this a very big example is dry ice, that is solid carbon dioxide. So solid carbon dioxide is nothing but it's obtained by applying a high pressure on carbon dioxide gas, and then if you want carbon dioxide back, you can just reduce the pressure by lifting up the piston. So the pressure will be reduced and then you will be getting back carbon dioxide. If you are increasing the pressure, you will be again getting solid CO2, which is known by the name known as dry ice. Okay, that's it for today. Thank you for watching. Subscribe to my channel if you have not done so far. Like and share this video to whomever you know. Thank you.